Welcome back, learners. So as we have said before the ad break, we're just going to now move on to our last concept of this lesson. Now that is going to be now looking at static electricity and friction in more detail. So let's begin. We need to know that static electricity, now that is the electric charge at rest on an object. So when we're talking about static electricity, we are talking about an electric charge that is at rest on an object. So when we're talking about static, what does static mean? When something is static, it means that something is not moving. It is stationary. So that means the charges of static electricity, they do not move because static means stationary or not moving. So therefore, the charges of static electricity, they do not move away from the object that they are in. So therefore, the object is going to keep its charge. Why? Because we're talking about static electricity. Static means something is stationary, something it is not moving. So if an object, or if you're talking about the charges of static electricity, then the object is going to retain its charge because those charges are not going to be moving away from that object. For an example, a charged comb that is picking up small pieces of paper due to static electricity. So as we can see on the side here, we have a comb that is picking up small pieces of paper due to static electricity. Remember when we're talking about the static electricity, we're talking about the electric charge that is at rest on an object. And because it's static, it is not moving. Furthermore, the loss of static electricity as charge move off an object, it is called electric discharge. Should it happen that the object loses its charges, then that loss of charge is going to be referred to as the electric discharge. In addition to that, discharging can take place when objects touch each other. So when two objects touch each other, then the discharge can happen. That's now when a substance is going to transfer its electrons to the other substance, meaning that one substance, it is going to, or the charges are going to move off from one object to the other. And when those electrons are moving off from one object to the other, they are being transferred to the other object. However, electrons can also transfer from one object to the other when they are brought close but not touching. So the two substances, they don't have to be in contact for the electrons to be transferred. They just need to be close to each other for the electrons to also transfer from one object to the other. So when electrons move across an air gap, so when the electrons are moving from one substance to the other without those substances being touched or without those substances touching each other, they can hit the air enough to make it glow. And we know when this air glow, we call that a spark. So you might have seen that whenever you're taking off your jersey, there are those sparks that appear there. Now that's now when your electrons are being transferred from one material to the other material. Why? Those electrons are going to heat up the air, then that air is going to heat enough to make a glow. And that glow, we call it a spark. So whenever you're taking off your jersey, and you see those sparks that when you're taking off a jersey, just know that the electrons are being transferred from one material to the other material. It's not magic. You should know what happens as a science learner. So now, sometimes the electric discharge that you're talking about, it happens so quickly that it happens so quickly to a point that we cannot be able to measure it. Now, what do I mean by that? When lightning happens, we know that lightning happens so fast. So now that's also another form or another example of electric discharge. We also know that the electric discharge can sometimes also happen slowly. Whenever you're taking off your jersey, when you see that spark, when you see that glow, we are saying that that's basically the electric discharge and it is happening slowly. So we have now those two examples of electric discharge. We can either talk about the lightning or we can also talk about that spark that we see whenever we're taking off our jersey. Now, these sparks that you're talking about here, they can be harmless, but they can also be very dangerous, right? Now, these sparks can cause flammable materials to ignite. So because now it's a spark, that spark can cause the flammable materials to ignite. Now, what we mean by flammable materials now, those are materials which can catch on flame easily. So because of that spark and those materials catching on flame easily, now they can then easily ignite. And when they easily ignite, they are now going to be very dangerous because they can cause fire. As much as we know what lightning does, it can also cause fire. So now if it comes into contact with a flammable substance, then fire can be caused there. In addition, you will probably have noticed that you may not smoke cigarettes on open flames near a petrol tanks. Now, whenever your dad or your mom or whoever that you know drives into a petrol station, you'd normally see signage there that tells them that they should not be smoking. They should switch off the ignition of their cars. Why? Because of this particular reason here, that the flammable materials, they can catch on they can catch on the spark and ignite. And once that happens, it can be very dangerous. Now, a huge fire can come from that, which is why we always need to be careful when we're driving into a petrol station. We need to always make sure that we're not smoking, that our ignitions are off, and also we are not having an open fire, not lighting anything, a match or a lighter of some sort. In addition to that, why do they then say this? This is because petrol fumes are very explosive and only needs a small amount of heat to start burning. As we have said, petrol fumes, they are very explosive, meaning that they are flammable. And once now they come across with just a small amount of heat, they will start burning. And that can then be very, very, very dangerous. Now, a small electrostatic spark is enough to ignite flammable petrol fumes, which is now can cause danger into, like, for everyone working at the station, even yourself that you are there at the station. So during a thunderstorm, there is friction in the atmosphere between the particles that makes up clouds, causing the buildup of regions of charge. So now when you're talking about lightning, this is where it starts. So during a thunderstorm, there is friction in the atmosphere between the particles that makes up clouds, causing a buildup of region of charge. Once the difference in charge becomes two regions, so that means now when it becomes great enough, the electrostatic discharge becomes possible. Remember, the electrostatic discharge can either happen slow or fast. If it happens fast, that's when we call it a lightning. If it's slow, we can use an example of that glow or that spark that we see. Now, a lightning flash is a massive discharge between charged regions within clouds or between clouds and the earth. So this is how now that lightning flash is coming about. Now, that is, as we have said, the lightning flash is a massive discharge between charged regions within the clouds or between clouds and the earth. So in order for us to be able to discharge the extra electron safely, we need to do something that is called earthing. So now, in order to discharge extra electrons safely from an object, we must earth that object. So what do we then mean by earthing? So earthing means that we connect the charged object to the ground, which is now the earth. That's where now the earthing comes in, or that's where that term earthing comes from. So we're going to now connect that charged object to the ground with an electrical conductor. Remember that a conductor is a substance that is able to allow or it is able to conduct electricity. So the extra electron, they travel along the conductor and enter the ground without causing any harm. Why? Because the earth, it is so large that the extra charge does not have any overall effect on it. So when someone asks you how does lightning come about or how is lightning formed, you just need to tell that person that lightning, it is caused by the imbalance of charges between the two regions. Now there needs to be the electrons that need to be discharged, and when they are discharged, they travel along the conductor and enter the ground, and then when they enter the ground, it doesn't cause any much harm to the earth. Why? Because earth, it is so big that the effects of it are likely to be less felt, or the effects of it, they are not really that much. So learners, what I need you to remember for this lesson is that the following. Number one, atoms are made up of protons, neutrons, and electrons. Number two, a neutrally charged particle can be charged by friction. That's now when you're rubbing that particular substance to a cloth or to something else. Number 3, and last and most importantly, that lightning is formed by an imbalance of charges between two regions. So until I see you next time, bye.